The National Electrical Code, or NEC, mandates a specific connection point for the grounding electrode conductor, or GEC, within the service equipment. This point is the neutral bus. The inspector is correct to point out that the GEC must land on the neutral bus. The reason for this requirement stems from the fundamental role of the neutral bus in establishing a common electrical potential reference point within the entire electrical system. The neutral bus serves as the designated point for grounding, ensuring that all circuits and equipment in the building share a common reference to ground. This facilitates the safe and effective operation of overcurrent protection devices during fault conditions. It's important to understand why simply bonding the ground bus to the neutral bus does not satisfy the code requirement for GEC placement. While the bonding jumper does create an electrical connection between the two buses, the code specifically requires the GEC to terminate directly on the neutral bus. This direct connection ensures the lowest possible impedance path for fault current to return to the source, aiding in the rapid clearing of faults and minimizing potential hazards. Section 250.24 of the National Electrical Code addresses connection to the grounding bus. The grounding electrode conductor shall be connected to the grounding bus in the service equipment. The language is quite specific in stating the grounding electrode conductor shall be connected to the grounding bus in the service equipment. This implies that the intention is for it to land directly on the neutral bus, which in a service panel is bonded to the ground bus. Section 250.59 covers the grounding electrode system. An effective grounding electrode system shall be installed to limit the voltage imposed by lightning, line surges, or unintentional contact with higher voltage lines and to facilitate the operation of equipment. The purpose of the grounding electrode system, as defined in section 250.59, is twofold. Firstly, to limit voltage surges from lightning, line surges, or accidental contact with high voltage lines, and secondly, to ensure proper equipment operation. This is achieved only when the grounding electrode conductor connects directly to the neutral bus. Connecting the grounding electrode conductor directly to the neutral bus ensures a low impedance path for fault current to flow back to the source. This low impedance path is critical for quickly tripping circuit breakers or blowing fuses, effectively disconnecting the faulted circuit and minimizing the risk of electrical shock or fire. Consider a scenario where a fault occurs in a piece of equipment connected to the electrical system. If the grounding electrode conductor is properly connected to the neutral bus, the fault current will flow through the equipment grounding conductor back to the neutral bus, and then through the grounding electrode conductor to the grounding electrode. This creates a closed loop that allows a large amount of current to flow, quickly tripping the overcurrent protection device. However, if the grounding electrode conductor is connected to the ground bus instead of the neutral bus, the fault current path may be less direct and have a higher impedance. This can slow down the tripping of the overcurrent protection device, increasing the risk of electrical shock or fire. Think of the electrical system as a network of interconnected pathways. The neutral bus acts as the central hub for grounding, ensuring that all circuits have a common reference point. The grounding electrode conductor provides the vital link between this hub and the earth, allowing fault currents to safely dissipate. In summary, the National Electrical Code mandates that the grounding electrode conductor must be connected to the neutral bus in the service equipment. This requirement is essential for establishing a common ground reference, ensuring proper equipment operation, and providing a low impedance path for fault currents to quickly trip over current protection devices. While the ground bus may be bonded to the neutral bus, this does not satisfy the specific code requirement for GEC placement. The direct connection to the neutral bus is crucial for electrical safety and proper system operation.